Welcome everyone to this next breakout session on the art of spatial data integration and visualization. My name is Matthew. I'm going to be the speaker for this presentation. First, a little about me. I'm a specialist solution architect here at Databricks for 2 years now. And before that, I was a software engineer, and I transitioned to a data engineer because I thought analytics and big data was way cooler than web development. And regarding geospatial experience, I work at Expedia and also for a telco company. And at Expedia, we were responsible for the backend, the search for when you search for a point of interest, hotels and region. This is my team that was responsible for that. We use PostGIS and Google Maps. So enough about me. We're not here for that. Let's focus on. I have today's mission. I have something for you. Let's provide explanation on UFO sighting, nonetheless. And how are we going to do that? We're going to leverage Geospatial Lakehouse to do that. And to do that, we need to ingest the data first from multiple sources, multiple formats. All of these are geo-reference. And we're going to also try to read data from ArcGIS to talk how to integrate with ArcGIS. Then the next step will be to analyze the data using Spatial SQL and H3 indexing. If you're not familiar with H3, we're going to cover that later on. And also, we're going to try GenAI. Why not? Let's try to find explanation, reasoning for UFO sighting using GenAI. And at the end, we need to serve the data, publish the results. And if you are curious and you want to use this repo, this is my source code. I'm going to share it with you later on. All right. I really like this quote by Carl Sagan, extraordinary claims require extraordinary evidence. So let's try to find evidence in the data using geospatial. I'm going to first do an overview on the platform. Geospatial data comes in multiple shapes and forms. And I'm curious if you could raise your hand, who is dealing with vector data? Lines, polygons, okay. Almost 60%. Raster data, images, satellite, okay, there's a bit less. Mobility, okay, cool. LiDAR, okay, yeah, okay, great. So just to let you know, we can ingest and transform this data using the Lakehouse. We have best practices for all of them. And let's focus more on the Lakehouse architecture. So the first step, it's the ETL layer to ingest data into the platform. We can ingest any spatial format, vector-based, raster-based, point cloud. We have best practices for each one. We have patterns. We support spatial indexing, coordinate system transformation, and we can also support batch mode and streaming mode, depending on your use cases. So this is for ETL. Regarding warehousing, built into the platform, we have ST function, we have H3 indexing, and what's going to be announced as well this week in Summit, we're going to have a native geospatial type, geometry, geography. So stay tuned on that. Our SQL platform is open and ANSI compliant. So if you're familiar with traditional RDMS databases like Oracle, SQL Server, PostGIS, you won't be lost. You can use these functions and all the language capabilities. Regarding the storage layer, this is pretty interesting. We are open data lake, and that enables you to store your geospatial and non-spatial data at the same time, at the same place, co-locate it. So you don't need different platforms to do that. That creates silos. And storing this data along your non-geo files, you can develop application on top of that, dashboard, machine learning model. So your end user, they don't need to work with different platforms that are segregated and copy data back and forth. And we support most geospatial format, the WikiT, the WikiB. And again, something I mentioned, we're going to have our own built-in spatial type coming soon, this week actually. And what is interesting with our storage layer, we have predictive optimization through Delta Lake. And you don't have to worry about partitioning, indexing. This is done for you. You can focus on developing applications. This is a higher level overview of our platform. We have the different sources at the left. And then you can bring the data inside the platform using a specialized tool like FME by Safe, or using our own tool called Lakeflow Pipeline. We're going to go over that in a minute. And in the center, you have the data intelligence platform. And what is interesting with this platform, it's flexible. You can use our own Spatial SQL product, or you can also leverage a specialized tool like Carto Toolbox, GeoPandas, Xarray for any type of use cases. And we can scale easily. You know, I have customers that use Databricks for small data set, and I have customers that deals with petabyte of information. So you are priced accordingly. You can still use a platform for small CSV and small use cases. No worries about that. And regarding on the right, this is where you have your consolidated enterprise data, where you can visualize, consume the data. Your data analyst can use SQL, can write SQL queries to interact with the data. Your non-technical user, your business users, can use Genie. This is our product to interact with native language, natural language. We support multiple languages, English, Spanish, Latin. Yeah, maybe not Latin, but you get the picture. Using English, you can interact with the data. And the good thing about Genie, you can even display map in this product. So your non-technical user, or even me, I'm using it, I'm lazy. Sometimes I just want to have an information, and I just hit I type it in simple English. And GIS analysts as well can use all these features, but also they can use their own tools. We support Carto, ArcGIS, PostGIS, something we're going to go over later on, BI tools as well. So we have integration as well with the external world. This is an overview. Now let's dig deeper. Let's ingest the data. This is our reference architecture. Is there anybody in the room familiar with medallion architecture? Does it ring a bell? Not that many people? Okay, so in a nutshell, you have different zones, raw, refined, enriched. Sometimes it's named differently, bronze, silver, gold, but it works the same way. You refine the data at each layer. You have your native files there, GeoJSON shapefile. You bring them in the platform. We recommend to use Delta format because you get all the benefits, predictive optimization, transaction, statistics. We have built-in readers to read vector data like JSON, XML, CSV. And if you have any gap, if you are working with customized data set like really specialized format like ZAR, LiDAR, you can leverage a specialized library for that, like raster, IO, Xarray. So we are a flexible platform. And then at each layer, you validate, you refine your data, you apply your indexes. At the end, you have the final product, the goal, the single source of truth. And at the goal layer, this is where you can consume it using an external tool, BI tools, or using various interface, SQL APIs, Python APIs. And also to bring data in, you can leverage, like I mentioned, specialized tool like Safe, or you can also use, we have our own ETL pipeline called Lakeflow Pipelines. It used to be named DLT, Data Live Tables, but it was rebranded for Lakeflow Pipelines because it sounds way, way cooler. And the way it works, it's declarative pipelines using Python or SQL. And then Databricks going to manage the full pipeline for you, the deployment and also the maintenance. And what is interesting with Lakeflow Pipelines, you can see the different progress of your pipelines. You see as well the matrix. You can define data quality on top of your data. So you can see which record are dropped or are clean. If there's any task failure, you can resume this specific task. And also what is coming during this summit, but I'm going to announce it to you as well, we're going to have a no-code, low-code solution called Lakeflow Designer. But it works the same way. It's going to produce the same kind of output. And to orchestrate all your job, you can use workflows. So workflows, it's our orchestrator, and it can organize and schedule all your jobs. It could be notebooks, pipelines, a shell script. So this is to bring data into the platform. We recommend to use volumes to manage your non-tabular data. So if you have any shapefiles, TIFF, LiDAR data. You can use volumes. This is a special kind of object in Unity Catalog. You have your traditional databases table, and volumes is a special kind of object to deal with non-tabular data. What is interesting with Unity Catalog, you get the lineage. So as soon as that data lands into the platform, you can track it, all the transformation logic that was applied on top of that to produce the final output, the final goal layer, either machine learning model, your model, or your table. Everything is searchable, crawlable, indexable as well using UC. Let's focus on how to integrate with ArcGIS. Many customers use ArcGIS. Is there any S3 customer here in the room? Yeah, okay, almost half of the crowd. Okay, let's focus on the first option. There's S3 Geoanalytics Engine, GAE. And it's pretty simple to use. It's a library you can install on your cluster directly. And it supports the latest and greatest version of DBR. What is interesting with this library, out of the box, you can use Spark to query your data that sits in ArcGIS Pro Online Enterprise. So natively, they support integration with your ArcGIS instances. And they bring a lot of different options to do buffering, clustering, spatial join. They even have spatial analytic to find a hotspot, similar location. And so if you are dealing with large data set, massive data set, you can use that. Second option is to use a Python ArcGIS module. Again, this is pretty easy to install. If you're familiar with Python world, you pip install in your notebook or even on a cluster. Bear in mind, this module is by default, for Python library, it runs on a single server, single node. But what is interesting with this module, you can access your feature layer and your web map directly from ArcGIS Online in Enterprise. You can display the maps in the notebook using display HTML. You can perform geocoding, enrichment, routing. And also, if you need to distribute the workload, there's always an option to convert the data frame, the Python data frame from this library to Spark, and then run your code on clusters. This is another option. And also, the last option is a Spark data source. So since DBR version 15, you can create your own data source using PySpark, using Python. So this is something I did. I have wrote a custom data source to retrieve data directly from ArcGIS, REST APIs. And what is interesting with that, you can develop APIs to do streaming, to even write back to ArcGIS. And what is interesting with this solution, you don't have to install anything. It uses Spark data frame under the hood, and you can combine it with Spatial SQL, Databricks solution to process large data set efficiently. So these are three options. If you're not familiar with ArcGIS REST API, this is something that is available right away if you go on the feature server. This is the UI, if you have never seen it. And what is interesting with that, you can query your instances live. And there's a bunch of options. You can define a where clause. You can define the output field. You can even redefine the coordinate system, the output. So this is what I use under the hood to retrieve the data in the Lakehouse. And also another option, I wanted to share it with you. This is a work in progress. If you want to also connect directly to the Lakehouse from your ArcGIS UI, S3 is currently working on a native CDW connector. Unfortunately, I don't have any date for you, but still I wanted to share the information. So stay tuned on that. They were waiting for the Databricks Spatial SQL public preview, which is coming pretty soon. So we've ingested the data. The next step now is to analyze and transform it. And to do that, we have built-in geospatial function. At this date, we have HAPIs, we have Spatial SQL function as well. And the interesting thing about those functions, they are available everywhere. In your ingestion pipeline, like flow pipelines, in notebooks, in SQL, and also you can use them with serverless or with classic compute as well. And if you find any gap in the platform, like I mentioned earlier, it's a flexible platform. We don't force you to use these spatial SQL function. You can also install GeoPandas, Sedona, raster, and the good thing is most of the time they work well together. There's no clash with the namespace, so you can combine them. No worries about that. If you're less familiar with H3 indexing, who ever heard of that, H3? Okay, oh, well, almost, again, after the crowd. I like that. So it's a grid index. It's similar to S2 by Google or even GeoHash, if you ever heard of that. And the way it works, it's a bit different than traditional indexes you find in databases, which use a hierarchy. And the way it works, it breaks down the world in multiple tiles, hexagonal tiles, like stop sign. And you can define different resolution, depending on your use case. 1 up to 12. 1 is the coarser. It overlaps countries and continents, like here. And 12, it's really up to millimeters. So in inches, it's, I don't know, like a couple of inches. And then here, you see like for Manhattan, you see the cell ID for the island. And you can use that to perform your spatial join. We're going to go over that in the next slide. So this is our reference architecture to use these indexes. You start from the raw zone. You apply the Medallion architecture. You refine your data. You ingest. You have your polygons. You have your points. They are all in Delta Lake format. You refine it. You clean it. You validate it. And then in your silver layer, this is where you can apply these H3 indexes. You can also specify multiple resolution depending on your use cases. It really depends on if you need to be accurate or not. And then the join happen on those cell ID, which are unique. Under the hood, they are longs. So that's why the join is really efficient and fast, because you're joining on 2 long. And also, we have a special kind of pattern. If you need to be super accurate, you can combine the join on H3 indexed with geospatial function, with geometry function, like intersect or contains. So this is a way to do it, and then get the final output. And also, what is interesting with the platform, you can use LLM directly in your SQL. So this is something you can use as well for your geospatial needs. And the way it works, you don't have to be a machine learning expert, a big brain. You just use AI query. You specify the model you want to use, either in-house model or a public one like Claude or OpenAI. You define your prompt. You can give variables, and it will give you result right away in a plain SQL statement. And you can use that to do add a query, to do enrichment. And what we have built in the platform, we have a bunch of different functions to do classification, sentiment analysis, masking. So this is pretty interesting as well. So we ingested the data, we analyze it, now it's time to serve it, to visualize it. Again, we have a bunch of options for that. You can use map visuals. This is directly available in the Lakehouse, in Databricks. And at the moment, we support markers, so lat longs, points. You can display that on maps. We support choropleth maps. And also, we are currently working to bring more complex types, like polygons, geometry, geographies, and also H3 cell IDs. And what is interesting with that, it's available in SQL Editor, in Genie, so the feature to interact with natural language, and also in dashboards. So you can create dashboards with maps, and you can share that with your end user, with your stakeholders. And the interesting about dashboard, your end user don't have to have an account in Databricks to use it. So you can embed these reports in your intranet, your extranet. So this is an option. The other option is to use Databricks Apps. So if you have more complex use cases, you need to create like interactive apps. This is an option. If you're not familiar with that, it's a self-contained web app that are hosted and managed by Databricks platform. They are pretty easy to use. It's a straightforward process. There's a nice UI to create them. For now, we support most Python frameworks, such as Dash, Radio, Streamlit, and Shiny. So you don't have to write any like JavaScript code or HTML. You can define everything in Python, and there's a bunch of options. And what is interesting with this solution is you can create interactive apps, predictive analytics, GenAI, and obviously, I mean, it's a geospatial talk. You can write and create Databricks geospatial apps. And it's up to you, like which mapping widget you want to use. You can use OpenStreetMap, Google API. And what is interesting with apps, it integrates with your data directly. So there's no, it's not hard-coded like the data. Here, like you can send query to your warehouse and retrieve your data in real time. Same thing for GenAI, you can create your machine learning model in real time. So it's not a hard-coded graph. And if you are interested in that, you can see there's a link there, Databricks Apps. I hope I can share the content with you afterward. And another option as well, we integrate with BI tools. I'm going to focus on Power BI today, but we support as well Tableau, and also ArcGIS, and also I have customers that use QGIS as well. Okay, but for today, I'm going to focus on Power BI. And the way it works, the Power BI service can retrieve the data using the warehouse, and then you can import it or use direct query if you're familiar with those concepts from Power BI. And it's a pretty easy and straightforward process. Nowadays, we release, I think it was this year, we released a one-click button that is similar to Buy Now on Amazon, and it does everything for you. In the catalog, in UC, you can specify which tables you want to publish to Power BI, and automatically it will create the semantic model for you. And you can define which storage mode you want to use. But if you need all the feature, the full-fledged experience, you can still use the Power BI desktop connector. It's still supported. So if you need to have more control. And when you are in Power BI, there's a couple of options to display geospatial data on maps. They support choropleth using fill map. And what is interesting, Microsoft supports different addresses in the world to define boundaries on the counties, states, neighborhood. And you have your go-to map. This only supports lat-long points, but you can do a cool thing. You can redefine tooltips and the size, the colors. And also, what they support is ArcGIS map for Power BI. What is interesting with this option, there's a free version available. But obviously, if you are a S3 customer, you can connect to your data directly from Power BI. And then you can have multiple layers. You can superpose, overlap your layers coming from ArcGIS with the data coming from Databricks. So this is a great option. All right, we are right on time. I like that. I'm going to try to do a live demo because to put it all together. That's great. I'm pretty sure it will work fine. All right, so we have our catalog. I have my tables, my database for the summit. And the first thing I'm going to show is Power BI. So it's pretty straightforward. We have this button here, Publish to Power BI. And then you can specify the workspace you want to work with. And you can define the query mode. You can also select the tables. I already done that before the meeting, so you can trust me, it works. And what it does, if you go in Power BI service, you will see your semantic model that was created automatically. So you can see your different relationships that match what you have in Databricks. So here I have my fact table, my UFO sighting, because if you remember, we are trying to find reasoning for sightings. And we have the dimension as well, counties, cities, and airports. So this is for Power BI. And if I go back in my repo, this is the repo I've shared with you previously. I have my source code, I have my notebooks, I have my data. The first step is we need to ingest data in the platform, like we saw in the first section. The UFO sighting comes in a CSV format. It's georeference. There's lat-long. I define the schema because there's no header in the file. I convert the lat long to a geometry because it's easier to work with. And then we can explore the data right away using SQL. So most of the sighting, the shape are light and triangle. And let's check like the moment of the day these sightings were reported using like this query. And then we can see like most of these sightings happen during nighttime. So I don't have any explanation, maybe like aliens sleep during the day. I don't know. I don't have a reasoning for that, but it's pretty interesting. So I ingested the sighting. In the notebooks, there's different technologies as well to display maps. I use Folium. This is an option. And here I can display my lat long on a map. You can show a tooltip. You can redefine the marker. So this is great for analysis. So I have my sighting. Now I want to bring data from ArcGIS. So I use my custom data source that I created. It's really straightforward. You see, read format, ArcGIS. You just need to define a URL. And also you can override the where clause if you want to filter data. Same thing for output field. But for now, I want to bring everything. So I've ingested a couple of dataset cities. I want to check. Maybe there's explanation there if most sighting happened in cities because maybe it's because of lighting or skyscraper. There's more object in cities. So this is coming from ArcGIS, cities, airports. As well, I want to check if maybe if it's close to airports. That could explain sightings. And counties. Counties because I want to maybe detect cluster. Is there any you can try to find patterns in the data if all these sightings happen in a specific region in the States. And this is the result you get when you use this API. You get a unique ID for each record, a feature type, a geometry as a GeoJSON, and the properties as a map. And then you can use that to persist your data set into the Lakehouse in data format. And also you can display polygons using Folium like that. So we've ingested our data. Now we want to transform it, analyze, find patterns in the data using a Spatial SQL. Again, this is something we showed earlier. So the first thing I do, I perform a search within a radius to just give them an idea. Okay, there's a lat long, a point. Now I want to retrieve the sighting near that. It's something interesting to explore. And then the next step is to do the join. So most of my data set, they use lat longs. So I have lat longs in sighting, in airports, in cities. So it's a bit tricky to join them together because we can go naively and try to join all airports with all sighting, but it won't be performant. It won't be efficient because I know for a fact my airports in New York won't match like my sighting in Texas. So it doesn't make sense to do that. So the way we're going to do it, we're going to use H3 indexing to perform this calculation. And I have an image. Maybe it will be easier to understand because it can be a bit tricky to understand the first time if you've never done that. I convert my lat long to H3 indexes. If you remember, these are unique in the world. They are cell. They are long. And they are like in the yellow. My sighting are in the yellow or light orange. My airport is in darker orange. So as you can see here, even if it intersect, it's not a match. Even if these points are near, they won't match like the cell ID. So what I do, using H3, we have a function as well to retrieve the parent of these cells. So in blue, I have the parent of my UFO sighting and my airport. And now we have a match. And then I'm going to show you the actual code. We have a match. We match on the parent. And then we can use a geometry or geography function to be more accurate because I want to keep a match within a distance of 10 kilometers. So this is something you can combine as well. You can combine H3, which are more coarser but are faster way to join, and then you can combine it afterward with intersect, contains, or in my case, distance, because I want to find airports that are close by. And then we get the result. We get if there's any match or not of an airport. Sometimes we get even multiple airports. So I do the same trick for cities. because it's lat long as well. Now, regarding counties, it's a bit different because counties, it's really like a polygon with a boundary. So I'm going to use a different trick to do that. And also, I wanted to show you that I've used PySpark to do like the first section of my notebook, but also you can intertwine it with SQL. You know, there's both options depending on which language you prefer. So I use SQL here. So the way it works is we're going to break down the polygon in multiple smaller tiles using this function, tessellate. And what it does, I'm going to show it on a map. I'm not using Folium anymore, I'm using Kepler. This is a really interesting library you can use in your notebook. And what is interesting with that, it's interactive, it supports a bunch of formats, WKB, GeoJSON, H3. And here we can see all the different counties in the states. And you can see, if you zoom in, you can see all the different cell IDs, all the tiles. And then we get the index, the cell ID. So I've broken down my neighborhood, my counties in multiple tiles. Now we are ready to join with the UFO sighting. And also what is interesting with that pattern is when you break down the original polygon, you can also like recover the original polygon. So you also have this information. So here I display the original polygon for Texas. So this is really interesting. You can have both of them. You can have the polygon plus the H3 APIs at the same time, depending on your need. And now I'm ready to join on the sighting and persist the information in a table. So I get all my matches, sighting matching to a county, to an airport, and to a city. And I have my final table. And now we are ready to have fun, to perform some computation. Let's try to find some trends. So here I found that most of my sighting happen in a urban location, close to 70%. I don't have a reason, but you know, let's continue. And the other one, airport close by, I get a 86% match. You know, this is a crazy number. So maybe that could explain UFO sighting. You know, they are close to our airports because maybe of lights. So this is something I could share with official or government. Maybe I found an explanation for UFO sighting. And also maybe we can try to find trend with population. So I've used, I group by county and sighting, and then I get a trend, and you can also display it on a scatter plot. So as we can see, below 1 million of population, there's no like correlation, but as soon as you hit this limit, like 1 million, there's more reports. But again, it makes sense. Maybe you know there's more sighting, there's more people to see the sighting. And also, what I'm trying to do as well in the next section, I'm going to try to find cluster aggregates. And to do that, you can use hull. And hull, it's a way to enclose all the points, all the lat longs, and it will give you like a convex polygon that enclose all these points. So this is an interesting operation if you want to detect cluster or aggregates, and you can display that on a map. So here you can see the different clusters, and you see this pattern, you know, like in major cities, in Vegas, on the West Coast. Here you have the mountains, and you have less people in the middle, but there seems to be a correlation between like large cities and number of sighting. But again, you know, maybe there's a correlation with there's more airports there's more lights that could explain sighting. And finally, let's try with LLM. So I'm going to use Claude. I'm going to use a prompt. Can you explain what would be the best explanation for this UFO sighting with the description, the location, the date time? And it come up with a possible explanation. So this is another option as well. And what is interesting with the LLM, I mean, for this sighting in '98, it knows it couldn't be drones because there were less drones at that time. but still, you have possible explanation as well. So this is interesting as well for geospatial data. This is something we saw in the presentation. And like I mentioned in the presentation, you can use these functions to enrich the data or perform ad hoc query. Okay, so the next step is to publish the result. I show you how to publish to Power BI previously. Now let's focus on the viz. So a couple of options here. You can display choropleth map. So here I display a choropleth with the number of sighting. And again, you can see like trend with in Vegas, in large city, you can display like the number of sighting in a tooltip. You can also display the raw data using a traditional map. And you can use slicer to filter the data. I use direct query, so each time I modify a value, it will refresh the data from the warehouse. So let's pick another city. You can see, I don't know if you've seen it, there was a loader in the left corner. So this is another option. And the last option that we saw as well in the presentation is to use ArcGIS. So you can combine data from the Lakehouse with data from ArcGIS. Here, what I did a layer, USC airports, just to give you an idea. And I displayed the raw value as well. And again, like we saw in the analysis, there seems to be a trend with the airport close by. I don't know, maybe this is an explanation. So this is for Power BI. And another option as well for more complex use cases, it's to use a Databricks Apps. It's pretty easy to use. You go here in Compute, Apps, you create an app, you can define the framework to use, and then you get an app that is hosted in Databricks. I've used Dash and Kepler to create this app. Okay, let me refresh. Okay, it works. Okay, so I use Kepler. And again, nothing is hard-coded. The data is refreshed live. And using Kepler, you can zoom in, zoom out. I displayed a choropleth map. So again, counties, and you get a color scheme based on the number of sighting. So red, more sighting, light yellow, less sighting. And like I mentioned with Kepler, you can define a bunch of things. You can override the theme, the colors. And also you can specify a county if you want to look at a specific region. And again, this is interactive. So here I display different information. I display the boundary of county. And also I display the individual sighting. And with the tooltip, you have the different information, the description, the date, time, airport close by. And again, everything is interactive. And I've added as well a call to Claude to give me a possible explanation for these sighting in these locations. So as we said today, it's pretty easy to ingest, transform, and serve geospatial data. I hope you enjoyed your presentation. Yeah.